In today's session, we just recall what you have studied in the previous session, that is session 2, and then we go for today's topic, that is production of pulp by sulfite process. In the last session, we have discussed about the chemical recovery from the black liquor. That black liquor is obtained after washing the digested wood in the craft process. The black liquor contains, that is lignin rich liquid in the Karitaragana, produced from the sulfate pulping process, contains about 95 to 98% of the chemicals added to the digesters. So to avoid air and water pollution and to maintain the economy of the pulping process, these chemicals has to be recovered before disposal of that water into flowing fluid or flowing water or streams of water. The black liquor is concentrated, burned, and lime to produce this sodium hydroxide. The chemicals which are present in the cooking liquor are sodium carbonate, sodium sulfate, soda ash, sodium hydroxide, sodium chloride, sodium sulfide. All these chemicals will be added as cooking liquor in the digesters. So 95 to 98% of these chemicals remains in the black liquor. The black liquor is treated for the recovery of all these chemicals in terms of sodium hydroxide. Here in the process is the black liquor is concentrated in multiple effect evaporators and disc evaporators. The concentrated black liquor, which is concentrated from 15 to 18% of solid content to 60 to 65% solid content. To this concentrated black liquor, makeup chemicals like sodium sulfate and elemental sulfur are added, and then the organic carbon which is present in the black liquor, that is from the lignin content, is burnt in a smelting furnace, supplying the necessary heat and carbon dioxide to produce an inorganic melt, that is in the form of slag, or it is known as smelt. Makeup alkali is supplied, such as sodium sulfate. The molten chemicals from the smelt actually dissolves immediately with cold water. That means from the furnace, the molten smelt is actually dropped into the cold water or with the green water, which is containing sodium carbonate. The insoluble impurities such as unburnt carbon and other materials actually settled out, and the clear solution is then casticized by adding milk of lime. This green liquor contains sodium carbonate. When sodium carbonate is subjected to casticization process, it is by treating with calcium hydroxide. It gives sodium hydroxide and calcium carbonate. This calcium carbonate is separated by filtration. The solution is sodium hydroxide, which can be recycled to the digesters. Right. The calcium carbonate thus obtained is calcined to calcium oxide, and this calcium oxide is dissolved in water to give milk of life. Let us see today's topic is sulfite pulping process. The sulfite process involves digestion of wood in an aqueous solution containing calcium bisulfate and excess sulfur dioxide. The sulfite process involves principal steps of reaction. 1. Sulfonation and solubilization of lignin with sulfite solution. Second one is hydrolytic splitting of cellulose lignin compound. The hemicelluloses are also hydrolyzed to simpler compounds and extraneous wood compounds acts on it. Since the disposal of waste liquor is a serious problem, attention has to be given to its removal and utilization. A slurry of magnesium oxide is substituted for lime because chemicals and heat recovery are possible and disposal problems of waste liquor is also minimized. Sodium and ammonia are also being substituted for lime in a limited way. Calcium bisulfite from the waste liquor does not decompose to sulfur dioxide, hence it can be used again, whereas magnesium bisulfite and thus decomposes to sulfur dioxide, and that is calcium sulfate is formed and lost. Hence, newer processes are based on magnesium sulfide rather than any other processes. Let us see the flow diagram. Chemical reactions involved in the preparation of cooking liquor. Sulfur is oxidized to sulfur dioxide. Sulfur dioxide plus water plus calcium carbonate gives calcium bisulfite and carbon dioxide. Sulfur dioxide plus water plus magnesium carbonate gives magnesium bisulfite and carbon dioxide. Sulfur dioxide reacts with magnesium hydroxide and gives magnesium bisulfite. Sulfur dioxide plus water plus ammonia gives ammonium bisulfite. The cooking liquor bisulfite of calcium, magnesium and ammonia are prepared in this manner. This is the flow diagram for sulfite process. Right. Let us see the process here. Sulfur is melted in a tank heated by a rotary burner. Sulfur vapors are burned in a combustion chamber to sulfur dioxide in a controlled atmosphere to avoid the formation of sulfur dioxide. Sulfur dioxide is cooled quickly in a horizontal or vertical or pond coolers consisting of a system of pipes surrounded by water. Sulfur dioxide gas is absorbed in water in presence of calcium or magnesium or ammonium compound in a series of two or more absorption towers or acid making towers for magnesium bisulfite. The liquor contains about certain amount of free sulfur dioxide. The final liquor is a solution of calcium, magnesium or ammonium bisulfite containing about 4.5% of total sulfur dioxide and 3.5% of free sulfur dioxide. The digester in this process are filled with chips, that is wood chips, and acid cooking liquor, that is calcium or magnesium or ammonium bisulfite solution, is pumped at the bottom of the digester. The digesters are cylindrical steel vessels with a capacity of 1 to 20 tons and 10,000 to 2 lakhs liters of acid. These digesters are lined with acid resisting material to avoid the corrosive action of liquor. The digester is heated by direct steam or by circulating hot cooking liquor which heats the mass uniformly. Cooking conditions varies in the digester with the type of wood and cooking liquor usually used. The cooking condition varies with the type of wood and cooking liquor usually. Pulp from the blow tank is passed through a series of screens to remove knots and lumps of the fibers, then centrifuged to remove the foreign material, then concentrated in thickeners and sent to bleaching unit. This is the how we can prepare the pulp by sulfite process. We can prepare the by sulfite where chlorine dioxide is introduced in the bleaching operation after chlorine has been exhausted. Milk of lime is added to neutralize the mass. The stock is then passed through a screen, thickened, dewatered, and dried with steam heated rolls and then baled. This pulp contains around 80 to 90% of dry fibers. Sulfite pulp is a high grade type of pulp used in the manufacture of finest paper including bond paper. It can be used alone or mixed with rag pulp to make writing and high grade paper. It is also used as a dissolving pulp for plastics and synthetic fibers, etc. Let us see some of the MCQs. Question number 1. In sulfite pulping process, cooking liquor contains dash. Options are sodium sulfate, calcium bisulfite, sodium bisulfite, sodium bisulfate. Options, right option is option B, calcium bisulfite. Question number 2. In sulfite pulping process, the digester temperature range is dash. Option A, 150 to 150 to 160 degrees Celsius. Option B, 160 to 170 degrees Celsius. Option D, 170 to 176 degrees Celsius. Option D, 180 to 190 degrees Celsius. ಡೈಜೆಸ್ಟಲ್ಲಿ ಎಷ್ಟು ಟೆಂಪರೇಚರ್ ಮೇಂಟೈನ್ ಮಾಡ್ತಾರೆ ಯಾವ ರೇಂಜಲ್ಲಿ ಅಂತ. ಆಪ್ಷನ್ ಎ ಇಸ್ ದಿ ರೈಟ್ ಆನ್ಸರ್, 150 to 160 degree Celsius. Question number 3. The dry fiber content in the sulfite pulp is dash. Options are dash percentage. Options are 40 to 50%. Option B 50 to 60%. Option C 70 to 80%. Option D 80 to 90%. ಎಷ್ಟು ಪರ್ಸೆಂಟ್ ಡ್ರೈ ಫೈಬರ್ಸ್ ಇರ್ತದೆ ಅಂತ. ಆಪ್ಷನ್ D is the right answer. 80 to 90% ನಷ್ಟು dry fiber content ಇರ್ತದೆ. Fourth question. Sulfite pulp is used as dissolving pulp for dash product. Options are plastics, option B, rubber, option C, nylon, and option D, rubber composites. The right answer is answer A in the production of plastics. Fifth question. The bleaching agent used to remove last traces of color bodies from the pulp is dash. The options are A. Chlorine dioxide, B. Magnesium oxide, C. Sulfur dioxide, option D. Boric oxide. The right option is option A. Chlorine dioxide. Thank you.